Okay, everyone, we're going to go into strings now. I have a whole bunch of other code that we can look at in a second, but let's just dive on into strings. So, character strings. This is where we left off last time. We were looking at ASCII tables, and then we figured out there's functions for ASCII characters, and we defined two upper. So let's look at strings themselves. A string could be two different things in C++, at least in C++. It could be a character string. That's what I know and love. There's also a string object. Now, those are native in Java. They were native in Python. I think they're native. They might be native in JavaScript, but they're not native in C. C used to have you do everything yourself. There was no shortcuts whatsoever. That is sort of the thing C is known for. It's you have to roll your own everything. So we are going to only be doing with C strings. Strings as an object, when we do BIT 2400, we'll see this. But in the meantime, for right now, we can't really do anything there's no string as an object. We're not dealing with objects yet because that's a whole other topic. So we'll be dealing with an array of characters. That's what a C string is. A character string or character array. And it goes like this. If I have something like hello, this string here, hello, what's actually happening without you seeing it is that the compiler is going to make an array of 1, 2, 3, 4, 5, 6 characters between position 0 to position 6. Position 5. No, 6. 1, 2, 3, 4, 5, 6. Okay, I have 6 characters in total, 0 to 5. Why do I know this? Because unbeknownst to you, the hidden secret ninja aspect of C strings is that there is a hidden null terminator at the end. It's completely invisible, you don't see it, but it's there. So my array looks like this, HELLO and a 0 in there. These are each characters. I have an array of size 6 with 6 different characters in there. And this 0 at the end. This is my null terminator. It's equal to the value 0, but you should use this. You should use this /0 character simply because did you know you were doing it, the null terminating character, or do you mean the character 0? Did you mean the number 0? What did you mean? Right? It makes sure that when you're looking at your code, you know exactly what this is supposed to be. It's supposed to be the character at the end of a string, not an accidental 0, not you doing math wrong. It is the character at the end of a string. Okay. Everything with 2 double quotes, I will make this array. And it's just an array of characters. So if I have an array of 1 character, well, we'll actually look at that when it comes to the quiz. So here is, I will have another thing pop up in a second. Here's a single character, C, right? It is the value A. It is 1 byte. Hello world, this thing is 15 characters, and I'm going to put this text in that array with 15 characters. Notice there are not 15 characters here. There are actually 11 characters here. So here's C. It's just in the bucket. I'm going to put the character A. Here is this string S. Here are my 15 buckets, my array of 15 different characters. And notice what happens. I don't need to use up if I don't have this 0 at the end, what happens? I would need to have my array be exactly the size of the text I'm using. I couldn't have any extra spaces, any extra things in there. And if I wanted to put other text in there, I'd have to make a whole new array with all different characters. What I want to be able to do is put a message in my array and automatically know where the end of the message is. So instead of going all the way to the end, having to fill this in with blanks or some other kind of thing, what I want is I want all the characters in here, and when I get to this here, I know I'm at the end of my string. I don't have to go any further. So when I want to print out my message, I print things out until I get to the 0 and I stop. I don't go to the end of my array. I go to when I find the 0. This allows me to have the length of my message being different than the size of my array. The message is not 15. The length of this message is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 characters long, right here. This is index 11, but the length of my string is size 11, the 0 as at position 11, the string itself, the text itself that I'm outputting is at positions 0 to 10. I need 12 characters. I need at least an array of size 12 in order to store all of this stuff. 0 to 11. I need 12 different spaces. I got more than I needed. I have 15. But if I don't have at least 12, I'm in trouble. So that leads us to the next quiz. I would like you guys to try and take this, and then we're going to get back to strings. I will not go over the answer for this quiz right now, but hopefully it will start making sense. So it's a difference between a string and a character. And remember, our string has a hidden 0 at the very end, no matter what. Including an empty string will have a hidden 0 in there. Okay. So we're going to look at Visual Studio in a little bit. We can actually look at the variables. I'm going to do it in the slide here, but we can actually put a breakpoint and look at our character array. Open it up, look at what's inside of it. So I can put my breakpoint down, and I can run my program, put my breakpoint down at somewhere, and look at what's in my array of characters. We'll do this in the lab, but let's have a look right now with this hello world with 15. What do I get? Here is the address where all of this text is. That's what this number here is. If you can see my pointer. Let's do my mouse here. Maybe make it easier. Here we go. Here's the address where everything is. And here at position 0, I have an H. Position 1, I have an E. I have position 2, I have an L. All the way down, position 11, I put a 0. That is the /0. And then 12, 13, 14, I don't know what's there. It could be anything, but I'm ignoring it. It's after the 0. And so what I have is just, it is straight up an array of characters. That's all we have there. There's nothing special. So I can also do this. So here is me making a constant size. Notice I did capitalization because it's a constant integer. Therefore, I can't change it. And therefore, I make it capital, all caps, to indicate that it is a constant. So that's going to be 20. I'm going to make a character array of size 20. I can then make the array equal Ottawa. And so I would have, so this is me making a brand new array with Ottawa in it. It will be size 7. Why? Because it has Ottawa 1, 2, 3, 4, 5, 6 characters plus the 0 at the end. This is an array of 20 characters that I can put other text in. This is an array of exactly 7. And if I tried to add another string that's even longer, I'll have trouble. You need to leave room for that 0 at the end. If you don't, you will have the bug I introduced to myself when I was preparing for 1400 last fall. So not this term, but the year before. And I had a bug in my code. And I went, oh, well, that's a good thing to point out to the class. I made this mistake. I made a string. I didn't have quite enough space for it. And so the 0 was outside of the size of, I used the length of the string to make a new array. The new array needed the length of the string plus 1 to store this extra 0 in there. If I don't have the space for that extra 0, I get random weird errors in my program. So the thing, it comes up from time to time. The length of Ottawa, the Ottawa string, is 6, but to store it, I need 7. Hopefully that makes sense. Okay. We also have things where we can get a string from the user. So we can use input white terminated space. So scanf uses white terminated space. If I put a tab, if I put a new line like a character return, I put a space, it stops taking in text. If I want a line of text, I think getS actually is what I need to use for that. The safe version of it is getS_s, and that has the size of the array that you're storing things in. For scanf, there is no real, I think scanf_s now has some kind of safety check, but with the original scanf, there was no safety check. If I didn't have a big enough array, it merely stuffed things in my array, ran out of space, started stomping on other people's data after the array. So I have this array, and I have the message, and I've filled the message, and I keep on going with scanf. Scanf underscore s says, okay, if your text is any longer than this, crash and yell at the user. So they are different beasts. I'm going to show get s, and I'm also going to show scanf right now, and then we'll have a look. So let's look at our code here. Okay, so I'm not going to be doing with malloc yet. That is going to, you can, at least for the time being, you can ignore this. This will make an array of 20 characters. That's what this thing is doing. It's a dynamic array of 20 characters. Let's see if I have a scanf here. Oh, there's a scanf. Numeric array size. How big is your array? So this will take in a single value. I want to see if I have a scanf in action. If I don't, I'm going to make one. String length of hello world. This string concatenation, and I don't have a scanf, so let's put a scanf in here. Character A, test text, and that's going to be size 20. And then I can have scanf. It might yell at me anyways, but let's put in a string. It's going to be a string going in here. It's going to be going into a test text, and I want a printf of write a short message less than 20 characters. And let's do a new line. All right. So scanf, I think it's actually gonna yell at you for the scanf here. At least Visual Studio and its infinite wisdom tends to do that. All right, you go. It may be unsafe. Why? Because if I just use scanf, and I can do this in Linux, if I just use scanf, the old traditional way of doing things, if I put in a message that is, let's say, 40 characters long, or if I do this and make it, let's say, 5 characters long, what's going to end up happening? I'm going to merely, someone puts in a string message of 20 characters long, it merely blows by, and let's make it 5. There we go. It merely blows by the end of the message, and bad stuff happens. So instead of that, I'm going to put a 5 here. I'm going to put a message into a test text right here, and the message can be at most 5 characters long. Do you see what the problem is going to be? Hopefully you do. So, underscore s. This is just a Google Drive issue. There we go. So, when I try and run my program, I will put in a message of length at maximum 5 into this into here. So 1, 2, oh, stupid thing. 2, 3, 4, 5. These are all characters, so it's a string. It's not where I can do A, B, C, D, E. But I want to push enter now, and let's see what happens. Does everything work? Let's have a look at test text. So there we go. What do I have? A test text. Something happened there. What the heck happened there? It may have actually saved me from myself without yelling at me. Notice I have a 0 in there to start. I should have put in a message into a test text, and nothing is in that message yet. Why? Because it is the string length is actually limited to being size 4. If it's any more than 4, I would have a problem. So let's make it 6. Hopefully that's going to fix its wagon, right? The length of my string has to be 5 characters at most. But if you give me, I need my array to be size 6 because I need that 0 at the end. Okay, let's do this again. 1, 2, 3, 4, 5. And now if I look at a test text, oh, it didn't actually, what's going on here? I'm wondering if I did something wrong with my syntax. So let's have a look at this. So scanf, it is going to underscore s, it's going to put this, the string, into a test text. It's going to give me a value of 5. Why is that not working? Let me look at this a bit more. Let me see here. A test text. I want to make sure it's the same thing. So what could be going on here? Scanf should return. Let's just stop this again. It should return a number of integers, the number of integers I'm reading in. Scanf should be doing this, so let's have a look. There's something weird going on. It's going to put this into this particular text buffer. It might, my parameters might just be a little off, but let's find out. Yeah, that might be the actual problem. I always forget scanf because they introduced scanf just last year. I was using the old scanf a long time ago. Oh, maybe this is still not the problem. Non-pointer to, nope, that's not right. Gotta be right. This is a pointer to this particular thing. It is of size 5. Why is that not working? Let's try it again. A, B, C, D. Okay, that one worked. Okay, let's try it again. A, B, C, D, E. So that's 5 characters. Does it still work? Nope. There you go. That's wild. Okay, so if my length of my string going in, the string that I put in there, I should need to put this as a 6. Okay. Including the 0, it turns out. See, these are the weird things you hit from time to time. This merely let me take in a string from the user, but if it was too long, it just said, no, we're not taking the string, and just ignores it. Doesn't give me an error message or anything, but it prevents me from going over the boundary of my array size. So let's try it again. A, B, C, D, E. 5 characters. The array is size 6. I can take at most 6 characters in. Let's see it in action. A, B, C, D, E. Great. Right here. The text is the right format. And if I do one more character, so let's do A, B, C, D, E, F. A, B, C, D, E, F. What do I get? I get a whole lot of nothing. Right? Doesn't even give me a warning. It just says, no, I'm just going to ignore that input. It was too long. Right? This is the kind of thing. Now, that's actually a good thing. It means that you're not going to stomp on past the end of your array. The old scanf used to go well past the array size and just start stomping on values. So in that respect, we want to be able to feel the reason why you need to have that extra. These kinds of bugs come up all the time. If I don't realize that I have an extra character for the 0, my array is going to go in wrong, and you're going to have a weird bug like, oh, the text message is not going in, which I just encountered myself in something I didn't expect. I thought this was the length of the string, not the length of the array, the size of the array itself. And you can always make your array just larger, but that doesn't actually solve the problem or help you figure out what the problem is. It just pushes it downstream. Okay, so it used to go past it. Now it just prevent with scanf underscore s. It just blows right past it. Oh, I wanted to do one other thing. Let's see if I can do a get s. Okay, and there we go. I'm going to make this size 200. Get s underscore s. What do I have in here? This is going to take in my text buffer. And it's going to the size of, and get the size of this, and it's going to then return a pointer to the front of this buffer. Okay, so let's hope that this thing is going to do the right thing. this is going to be size 200. I don't need to change this one up here. Just now I'm limited to 6 characters. And in fact, I'm just going to get rid of comment out these two lines here. Let's compile it. Let's see what happens. All right. So it's going to get user input, and we're going to write a bunch of characters in a row, and then we're going to look at it. Hi, how are you today? And my text message is, hi, how are you today? It was less than 200 characters, so it worked just fine. If I tried this with scanf, which let's try this now, what would actually happen? And let's comment out that. What do we expect to happen with scanf when we try and do this? Well, scanf only goes to the next space. So, hi D. And the text message is hi. Not hi D, hi. It got to the space and then just stopped. The D is just floating around somewhere. It'll actually be into the next message that someone writes. So, this is the kind of thing you would need to learn for scanf. Let's get back to CStrings. So here is my example for CStrings. Once again, I have hello. It has a 0 at the end. I can print off an individual character. So for this array at position 1, that is this E right here. Okay. If I just print off the string, and it's this var, this whole array, it will print off hello. It print out the whole thing, not showing you that terminating 0. That is a hidden 0. You never see it, but it's there when you look at the data. Here I'm going to make a new array. I'm going to take in, this is using old scanf. I'm going to take in this array. In this array, I'm going to put whatever message someone types into var2. The whole, whatever they type. And if it's too much, I blow by the end of my array and I have bad things happen. So it's kind of a dangerous thing to do. And that's why we use the _s. And if I want a single character, I can put this %C. I will only get one single character and it will go into position 1. It will go wherever that E was. It reads one character and plops it in here, right? In var2's position. So whatever was in var2, it'll plop it into position 1 in var2. So here we have another string example. It has 40 characters. And am I correct or not, right? It has a 2-character array for whether someone is correct. So please enter your name less than 40 characters. I will get a name. So this is the string that you're going to be putting things in. This is saying put it into it's a string that I'm going to be inputting, and it's going to go in here. And you entered this name. I'm just going to put the name here. And so here's my name right here. You put in this name. Is this correct? Yes or no? And so it's going to take in either yes or no, Y or N. And so I can do a scanf, figure out if, and it's going to be a grand total of 2 characters. And it'll be either Y or an N. So if it's a Y, or capital Y or lowercase y, name confirmed. Otherwise, rinse and repeat. Do it again. Notice, I like this example for one very important reason. What would have been a better way of doing this? The better way of doing this, notice this and this sort of match up, or actually this and this. So as a result, I should use a do-while loop in this case. I need to get the name in anyways, and when it's wrong, I can ask, is this correct, each and every time, and ask again. So I need to get the name in anyways. I need to do it at least once. That stinks of a time to use a do-while loop, in case you're wondering when to use a do-while loop. All right. We are going to stop there because I had a lot of dead time debugging what the heck scanf was doing, because these things happen. We do a little bit of code at a time, check that it works, move on to the next piece. We don't try and write all our code at once and then figure it out. Otherwise, we will go nuts. We'll have the scanfs being called incorrectly everywhere in our code. We want to do a little bit and then move on. When we come back next time, we're going to be looking a little bit more at this. Well, let me finish this off because we already looked at scanf and scanf underscore s, right? One takes in the size of the array that your things are going to go to. Great. This takes, because I have 2 inputs, it'll take in a name, it'll take in an ID. That's fine. This is only taking 1 parameter, but it also takes in the size of the array that I'm going to be using. So this actually should be, well, I'm limiting it to 39 just to make sure I have the space. We have one other thing, like printf, we have sprintf that allows us to write to an array. Sprintf, the S stands for string, and it's like printf, but instead of going to the screen, it goes to a C string. So I have, here's the C string it's going to go to, and I can put in this string and this string, there's a space in between, with hello world, and so what a name will have is hello world at the end. It works just like printf, but instead of going out to the screen, all the parameters, all the text goes right into my array right here. That's the one thing I wanted to go over. So when we come back next time, we're going to be looking at strings a bit more. We're going to look at the built-in string functions. Thanks, everyone.